Hello dear students, welcome to the last part of the chapter Aldehyde, Ketones and Carboxylic Acid, where we are going to discuss various chemical properties of carboxylic acid. Now carboxylic acid shows variety of chemical properties because of the presence of various functional group in them. Now we know this is the structure of carboxylic acid. Now various cleavages can be possible in this. The first cleavage, where hydrogen from hydroxyl group can be cleaved. Second cleavage, where whole hydroxyl group can be cleaved. Third cleavage, where whole carboxyl group can be cleaved. And fourth cleavage, where alkyl group will show different types of properties. So we have to study all these cleavages and the reactions shown by these cleavages. So we'll begin with this first one, where we are discussing cleavage of OH bond of hydroxyl group. And this is the important one because this cleavage is responsible for acidic character of carboxylic acids. Now since this bond will be cleaved and hydrogen will be released, we can say it will be responsible for acidic character. Any carboxylic acid, when it is treated with sodium hydrogen carbonate, gives sodium salt along with the evolution of carbon dioxide and water. We say there is a brisk effervescence of CO2, and this is a characteristic test. This will be characteristics test of carboxylic acid. So whenever you have been asked to chemically distinguish between a carboxylic acid and any other functional group, you can easily go for this test, which is the reaction of acid with sodium hydrogen carbonate to give brisk effervescence. Now the thing is that can all carboxylic acid give this test? Carboxylic acid, if it has pKa less than 7, then it will give this test. For example, methanoic acid has pKa 3.47, will give this test. Ethanoic acid or acetic acid with pKa 4.74, it will give this test with NaHCO3. But alcohol and phenol, they have their pK near about 10, and therefore they do not give the test with sodium hydrogen carbonate. I will say alcohols and phenols do not give brisk effervescence of CO2 when it is treated with sodium hydrogen carbonate, and therefore we say this is the characteristic test for acids. The next reaction of cleavage of OH bond gives us one of the acid derivatives, that is acid anhydride. I have taken example of acetic acid. When we are taking 2 moles of acetic acid and heating it with P2O5, then bond OH bond will get cleaved and OH bond from other carboxylic acid will be cleaved, resulting in the formation of acetic anhydride. So this reaction is an example of both the cleavages, cleavage of OH bond as well as cleavage of OH bond, along with formation of water. So we have to remember this reagent P2O5. Whenever P2O5 is treated with any carboxylic acid, it will give anhydride. And in the preparation of carboxylic acid, we have seen that the hydrolysis of acid anhydride gives us 2 moles of carboxylic acid. So now we will discuss reaction involving cleavage of hydroxyl group. One example we have already studied here. Generally, the reaction which involves cleavage of hydroxyl group helps us to give acid derivatives. What are acid derivatives? Acyl chloride, acid anhydride, ester. These are acid derivative. So one acid derivative we have already discussed here. Second one I am going to discuss, and that reaction is also known as esterification. We know the carboxylic acid, whenever it is treated with alcohol in presence of any catalyst such as concentrated H2SO4 or concentrated HCl, OH bond from carboxylic acid gets cleaved and hydrogen of the alcohol, thus giving us ester along with the formation of water. Now the thing is that the water formed has to be removed immediately. Otherwise what will happen? Otherwise hydrolysis of ester will take place. That means ester will get hydrolyzed back to the acid and alcohol from which it was formed, and therefore this water formed has to be removed periodically. Again, one more thing is that this concentrated acid which act as a catalyst, we need a very small amount of that. Let us take one example. Ethanoic acid, when treated with ethanol in presence of catalysts like concentrated H2SO4. Now we know the cleavage resulting in the formation of ethyl ethanoate, which is an ester. Next acid derivative which we are going to discuss is acid chloride. Carboxylic acid, when it is treated with any of the reagent like phosphorus trichloride, phosphorus pentachloride or thionyl chloride, gives us acid chloride. The byproducts will differ depending on whether you are using phosphorus trichloride, phosphorus pentachloride or thionyl chloride. Let us discuss one example. So ethanoic acid, when it is treated with phosphorus trichloride, gives us acid chloride along with the formation of phosphorus acid. With phosphorus pentachloride, we'll get phosphorus oxychloride as a byproduct, and with thionyl chloride, we have already seen that we get gases like sulfur dioxide and HCl as a byproduct. Next acid derivative which we are going to discuss is formation of acid anhydride. Formation of acid amide. Carboxylic acid, when it is treated with ammonia, the very first we get intermediate called as ammonium acetate. Now this ammonium acetate on further heating loses water molecule and gives us acetamide. In the methods of preparation, we have seen that the hydrolysis of acid derivative like acid chloride or acetamide gives us carboxylic acid. So you have to remember these things. You must be able to connect the reactions, that when we get the acid derivatives and the acid derivatives on hydrolysis will give us the same carboxylic acid back. Now the aromatic acids such as benzoic acid, when it is treated with ammonia, obviously first of all it will give the intermediate ammonium benzoate, and this on heating loses water molecule to give us benzamide. Now I am going to discuss one important reaction which we'll be studying again in the chapter organic compound containing nitrogen. Phthalic acid, when it is treated with 2 moles of ammonia, first of all obviously the intermediate ammonium phthalate. So we know all these things by now. This is ammonium phthalate. This on further heating loses water molecule and gives phthalimide. So up till now we have studied this. Now what is the interesting thing in this reaction? Now this, if when further heated, strong heating, will lose one ammonia molecule and gives us phthalimide. Now this phthalimide will be used in the preparation of 1 degree aliphatic amine, and that's why this test is, or this reaction is important one. Now the next reactions which we are going to discuss, it includes the cleavage of carboxylic group. In that first one we are going to study reduction. Carboxylic acid, we have already studied that they on reduction gives us the alcohol, and for that we need strong reducing agent like lithium aluminum hydride or diborane. And second step will be hydrolysis, gives us 1 degree alcohol. Now here you have to remember the reducing agent. We have to use lithium aluminum hydride. We cannot use the sodium boron hydride as it do not reduces the carbonyl group. Secondly, this diborane will be a specific reducing agent. Why? Because it does not reduces other group like ester, nitro, halo, etc. And therefore diborane or lithium aluminum hydride will be good reducing agent for this reaction. Next is decarboxylation. From our basic knowledge of class 11th, we know that decarboxylation can be done by using a mixture of sodium hydroxide and calcium oxide in the ratio of 3:1, and we call it as the soda lime. So it's not ascent of series, it's a descent of series or stepping down reaction. Carboxylic acid, when treated with mixture of soda lime, gives us the corresponding alkane along with the formation of sodium carbonate. The decarboxylation can be also done by using sodium salt of acid. For example, sodium acetate. Now when we pass electric current in this sodium acetate, we get ethane along with sodium carbonate. This reaction we have studied in our class 11, and it is Kolbe's electrolysis. So this is your name reaction from carboxylic acid part. Coming to the last part of the cleavages, reaction involving substitution in the alkyl part. In that first one, we are going to study our next stream reaction, Hell-Vollard-Szalinski reaction. It is also called as HVZ reaction. According to this reaction, the carboxylic acid, I have taken the example of propanoic acid, when it is treated with halogen in presence of red phosphorus, obviously followed by hydrolysis, gives us alpha halocarboxylic acid, where halogen can be either chromine or bromine. Halogen can be either chlorine or bromine. Now, why this reaction is of importance? Suppose you substitute here chlorine, then that can be further substituted by cyanide or ammonia, and we can get further products, like suppose we have substituted here cyanide, then cyanide, its partial reduction or its hydrolysis will give us the required product, and therefore this reaction is of lot of importance for the conversions. Aromatic carboxylic acid, they show ring substitution as their hydrocarbon part will be benzene ring. Now we know from our basic knowledge that carboxylic group is meta directing and therefore always will get meta product. For example, benzoic acid, when it is nitrated by using a nitrating mixture, we get meta-nitrobenzoic acid. So this is meta-nitrobenzoic acid. So although we have seen that the ring substitution takes place in aromatic carboxylic acid, but one of the important feature is that aromatic carboxylic acid do not show Friedel-Crafts reaction. Now why? Because the carboxyl group is deactivating. From our basic knowledge, we know all meta-directing groups are deactivating group, and therefore it do not show Friedel-Crafts reaction. There is one more reason. We are using anhydrous aluminum chloride as a catalyst, and it gets bonded to carboxylic acid, and therefore instead of going for substitution, it goes for the salt formation, and therefore aromatic carboxylic acid do not undergo Friedel-Crafts reaction. So all these were chemical reactions shown by carboxylic acids. Now since we are continuously discussing these are acids, we have to see their acidic character, how we can decide which acid can be stronger, and whether it will show other reactions of carbonyl group or not. So let us move on to the next topic. So acidic character of acids. Carboxylic acids are more acidic than phenols. We have already seen in the chapter alcohol, phenol and ether this range of acidic strength. Carboxylic acid more acidic than phenol, followed by water, and alcohol being the least acidic. Now the reason lies in the structure of carboxylic acid. Carboxylic acid shows resonance and forms carboxylate ion. Now as we can see in this carboxylate ion, this negative charge can be dispersed on two electronegative oxygen atom. This is shown in this hybrid structure, and therefore it becomes much more acidic than even in phenol or alcohol. But in case of phenol, what happens? Phenol can also show resonating structure and forms phenoxide ion. But in phenoxide ion, the negative charge is localized over only one electronegative oxygen atom, and therefore phenol will be less acidic than carboxylic acid. Now this is your important give reason question, that why carboxylic acids are much more acidic than phenol, water or alcohol. Now one more interesting thing. Now since this oxygen is involved in the resonance here, therefore I will say this carbonyl group is not a free group, as it is involved in the resonance, and therefore it do not show the characteristic reaction of carbonyl compounds. So we have seen two important give reason in this, that why carboxylic acids are more acidic than phenol, and second give reason why carboxylic acid do not show characteristic reaction of carbonyl group. The reason lies in the resonating structure. Now there is one exception to this point. The exception is of methanoic acid. Now methanoic acid, if we observe the structure carefully, this group can act as an aldehyde group, and therefore methanoic acid is the only acid that gives Tollens test. This is important because so many times two acids are asked to distinguish chemically, and in that case one of the acid will be as surely methanoic acid, and the student get confused that when two acids are given, how to distinguish them chemically. Methanoic acid will always give Tollens test, and this is the only exception for carboxylic acids. There are various factors which affect the acidic strength of carboxylic acid. The very first is effect of substituent. We have studied this topic in chapter phenols also, that electron donating group will always decrease acidic character. Why? Because they will increase the electron density on oxygen, polarity will reduce, and therefore release of H plus becomes difficult. Whereas electron withdrawing group increases the acidic character. Why? Because they promote the electron withdrawal. As a result, polarity increases and release of H plus becomes easier. So we can see examples here. Methanoic acid will be more acidic than ethanoic acid, more acidic than propanoic acid, and it will be more acidic than 2-methyl propanoic acid. Why? As the number of electron donating group increases, acidic character decreases. Now, based on this, you can be asked plenty of questions such as arranging in the sequence, give reason question. For example, this whole set is given to you and you have been asked to arrange them in either increasing or decreasing order. Or a give reason question can be asked that acetic acid is more acidic than 2-methyl propanoic acid. Reason is very simple, because of presence of more electron donating group. The second example, fluoroacetic acid will be weak acid as compared to cyanoacid, as compared to nitroacetic acid. Why? Because NO2 group will be strong electron withdrawing group. Similarly, chloroacetic acid will be strong acid as compared to ethanoic acid. Other factors are like the number of halogen atom, the nature of halogen atom, and the position of halogen atom. So the first one, as the number of halogen atom increases, we know minus I effect will also increase, and therefore acidic character will also increase. As a result, trichloroacetic acid will be a stronger acid as compared to chloroacetic acid. Now this question is asked many a times, that why trichloroacetic acid is much stronger acid as compared to chloroacetic acid. Now if the given halogen, if it has greater electron withdrawing strength, stronger will be acid, and in halogens we know fluorine has the strongest electron withdrawing character, and therefore fluoroacetic acid becomes a stronger acid as compared to chloroacetic acid and bromoacetic acid. Lastly, effect of position of halogen atom. If the halogens are closer to the carboxyl group, minus I effect will play its role, and therefore acidic character will be highest, and therefore closer the halogen group, higher the strength will be of acid. And therefore 2-chlorobutanoic acid will be stronger acid as compared to 4-chlorobutanoic acid. So based on this, arrange in increasing or decreasing sequence type question, give reason type question, comparison questions type questions can be asked. So just now we have seen various factors that affect the acidic strength, and therefore one acid can be stronger than the other. So how to decide, how to compare the acidic character? We know carboxylic acid, when they dissociate in water, will form carboxylate ion along with hydronium ion. So from this I can calculate Ka. This we already know from our 11th class equilibrium chapter. And we also know that Ka is directly proportional to acidic strength. or I will say pKa is inversely proportional to acidic strength. For example, I have two acids. Let's say case 1 with Ka 3.8 into 10 to power 2, and in second case I have acid with Ka 6.4 into 10 to power 2. Now suppose it is asked among these two which will be the stronger acid. So obviously higher the value of Ka, this will be stronger acid. So by considering the Ka or pKa value, we can easily compare the acidic character. So with this, we have completed the chapter. Aldehyde ketones and carboxylic acid is the most important chapter of organic chemistry. You have to go thoroughly through it as it involves lots and lots of conceptual questions. So based on today's video, you can try to solve these questions. All these answers you will get in this video. My dear students, again I am repeating, aldehyde ketone and carboxylic acid is one of the most important chapter, and therefore you have to be very thorough for this topic. So try to solve these questions. Thanks for watching. Have a nice day.